So let's revise everything, whatever we had studied in previous class, so that we can catch up with the next topics easily, inshallah. Okay, Laiba? Okay, let's begin with circles. Bismillah ar-Rahman ar-Rahim. Circle is nothing but, what is circle? You need to tell me everything now, okay? What is a circle, beta? Circle is?
Closed figure with
Yes, very good. It's a closed figure. What are the unique features of a circle? One is
chord.
no edges. It has no edges, no vertices. And there's one unique feature of a circle, that whenever you draw some point on
Center.
the circle, yes, any point on the surface of the circle, then it is actually equidistant from the center of the circle. That is, this distance is called as, what is this distance called, beta? From the center to the point on the circle, what is it called?
Radius.
Yes, excellent. Circle has a unique thing that is called as a radius. Radius is nothing but it is the center of the circle to the surface of the circle, right? Distance between center of the circle and to the surface of the circle. So circle is a figure that has no edges, no vertices, and it has a radius which is nothing but the distance from the center point to the surface of the circle. So radius is equidistant throughout the circle. Okay, this is about the circles. Okay, the thing that we are going to study in the curriculum of ninth is nothing but the chord. What is a chord? Chord is nothing but, yes, Laiba, what are you going to say about chord? Chord is nothing but a line, right? Joining the
Points of
2 points on the circle. Their point should lie on the surface of the circle, correct? This point should be on the surface of the circle, not elsewhere. Fine. Which is the longest chord? Can you tell me which is the longest chord?
diameter.
Excellent, because it joins the center. It joins through the center of the circle. So it forms the longest, largest distance and longest from the center, right? So the measurement of this chord is longest. So the chord that passes through the center of the circle, this is also called as a diameter. Fine. So what did we learn in the chord? The first thing that we had studied was angle subtended by a chord at a point. Fine. Angle subtended by a chord at a point का मतलब क्या होता है? If you draw a chord, then if you draw any point on the circle, for example, this is a chord AB. If you draw any point C here, or any point D here, or any point O here, let this be C, let this be D, and let this be O. What is an angle subtended by chord AB at C? How do you calculate this? You will draw an extra line to this. What is an angle subtended by AB to C? This one, right? What is an angle subtended by AB, line AB to the point C? It is angle, what is it, beta? A. Excellent. I will tell you what is an angle subtended by chord AB at O.
AOB.
Excellent, excellent, very good. What is the angle subtended by a chord AB at D?
ADB.
Excellent. This is what is called as angle subtended by a chord at a point. Fine. From this features, we have two unique theorems, right? What are your theorems that arrive from the angle subtended by the circles to the chord? What are the two theorems? The first theorem states. What does the first theorem states, Vita?
Equal chords of a circle subtend equal angles.
Yes, very good. Based on this property, based on the property of angle subtended by the circle, there is a unique two theorems that states that first, the angle subtended by two equal chords, if this is AB and this is CD, and if this AB is equal to CD, then the angle that is subtended at the center of the circle by AB and CD are equal, right? Yes. So equal chords subtend the equal angles at the center. This is about the theorem number 1. What is the converse to this theorem? Is it the theorem number 2, Laiba? Yes. Theorem number 2. What does it state, beta? It is just the opposite. Tell me the opposite of it.
The angles subtended by the chords of a circle are equal. Then the chords are
equal. Yes. If the angles are equal, then the chords are equal. The proof was very easy, right? Just you had to prove, what was to prove, beta? You just had to prove the angle equal here. There you had to prove the sides equal. There you had to prove the angles equal. Here you had to prove the sides equal. That's all, right? A is equal to CD, you have to prove theorem number 2. And theorem number 1, what you have to prove? In theorem number 1, you have to prove angle AOB is equal to angle COB, right, beta? Yes. How did you prove that? It is nothing but the postulate. Which postulate did you apply, Laiba? In the first thing, was it TSS's postulate? Yes. You had to apply two postulates here, right? And theorem 1 as well as theorem 2. So clear with these points? All of the points still here? Yes. So we had exercise 9.1. We did two separate congruent circles, and then we proved the same theorem number 1 for both of it. Correct? Here we had to draw one, and here we would draw another. This was the theorem number 1. You had to prove the same thing you had to write, but it's in two different circles. That's all. But two congruent and equal circles. That's all. And what about this one? You had to prove the same. Sides are equal. Chords are equal. AB is equal to CD, you had to prove, but the angle is equal. That is given already. Fine, Vita?
Yes.
Okay. So this was still here. It was about angle subtended by the center of the circle. That's all. And it angle subtended by the chord at the center of the circle. This was in the 9.1. Okay. What about 9.2? It is nothing but perpendicular from the center of the circle to the chord. Now, what are the two theorems that we had to arrive at after learning perpendicular from the center to the chord? After drawing a perpendicular from the center of the chord, we had two theorems. Which are those two theorems, Vita? Perpendicular from the center of the circle to the chord. We had two separate theorems. It's very easy. What did we say? Equal chords are? Yes. Equal distance from the center, right?
Yes.
Equal chords, equal distance from the center. This is a theorem number?
5.
Yes, it's theorem number 5 or 3. Okay, it's theorem number 5. Yes. What is theorem number 3? Is it not about the perpendicular drawn bisects the chord?
Yes.
Yes, AMB, it divides into two parts, right? AMB divides into two parts. If it is CD, it divides into two parts. What is equal to theorem number 3? Theorem number 3 states that a perpendicular from the center of the circle to the chord bisects the chord. इसका मतलब होता है कि it divides the chord into two equal parts. That's all. And what about theorem number 4? It is the same. That's the converse of theorem number 3. Can you please tell me what is the theorem number 4?
The line drawn through the center circle bisects a
Yes,
chord.
if it is bisected, then something from the center of the circle is actually perpendicular to that line. Is perpendicular to that chord, correct? Just the converse of theorem number 4. Theorem number 3. That's all, right? So 4 theorems in total we have studied now. Two equal chords subtend equal angles, and then the equal angles subtended, then the chords are equal, and then if you draw a perpendicular from the center of the circle to the chord, then it bisects the chord. And if something bisects the chord, then the line that is drawn is actually perpendicular to the chord. That's all. Fine. This is the theorem 4. Then theorem 5 and theorem 6. What does it state now? It's easy. It's quite easy. What was about it, beta? It is nothing but about lengths, right? Equal chords. What is the distance from the center? What did we study? Equal chords have the equal distance from the center, right?
Yes.
Right, Laiba? If this is a chord that are equal, then they actually form the equal distance from the center. All of the distance here are equal. So equal chords are equidistant from the center. Or the converse of this theorem, theorem number 6, if the distances are same, then the chords are equal, correct? The actual distance from any object can be carried out only after finding the distance between the center of the circle to the point. Fine. What is theorem number 5? Equal chords of the circle are equidistant from the center. Fine, beta? Equal chords of the circle, equidistant from the center. This is theorem number 5. What is theorem number 6, Laiba?
Chords equidistant from the center are equal in length.
Very good. Equidistant from the center are equal in length. This is theorem number 6. So we are clear with all the theorem 1 to 6. We are also studied about example problems, and we had seen almost 4 problems, right? Yes, in exercise number 9.2, we have seen all of the problems, mashallah. So you had any doubts in these problems, beta? Did you solve it at home once? No, right? While studying for the test or something, you just revise it, and if you have doubts anytime, anywhere, whenever you're going to study, please ping me, inshallah, I'll reply to you. Okay? These are all your problems 1 to 6. Problem 5 and 6 were quite easy, right? You just had to find the hypotenuse. Now, next, the fourth thing that we are studying is the arc. Is about arc. It's not about the chord. It's about the arc. Okay? Arc is formed from the chords itself, right? Arcs are formed from the chords, right, beta? If you divide something, if this is a circle, beta, fine. If you draw this chord, then now it forms two arcs, right? This line that is drawn forms two arcs. Which are the two arcs now? This part is one arc, fine, Laiba? This part is one arc, This part is another arc. What is this part called? It is called as minor arc. What is it called at? Minor arc. What is this part called, beta? Is it major arc? Yes, it is
Yes.
major arc. Fine, understood. So arc is nothing but it is a part of a circle. How can we find part of the circle? It is only found out when it is separated, right? When there is something that is drawn in between, right? So chord is important while drawing an arc, correct? Chord is important while drawing an arc. So how is arc formed? Arc is formed by joining 2 points on the circle, correct? So endpoints of this chord of a circle cuts the circle into 2 equal arcs. One is a major arc, one is a minor arc. So if you have equal chords, then what happened? Equal chords ka matlab kya hota hai? That is nothing but this one, right? If you have one chord here and one chord here, does it divide into two same segments? Yes. It is a minor arc here. This minor arc equal to minor arc, correct? If you have equal chord here and equal chord here, correct?
Yes.
It forms 2 minor arcs. These 2 minor arcs will be equal in length, fine? So what if you have equal chords? Then equal arcs will have equal this one. So there is one property of circle. If 2 chords of a circle are equal, then their arcs are also equal or congruent, fine? This is the property. You don't have to memorize this. You just have to remember this, okay? Next, you are going to find some theorems based on this. If 2 arcs are congruent, then their corresponding chords are equal. The converse of this is just the properties of the circle, fine? You do not have to memorize this. But remember it, okay? If you have drawn the 2 equal chords, for example, if you have drawn chord AB and CD, beta, this arc, minor arc, is equal to this arc, okay? समझ में आ रहा है? This arc is equal to this arc. Why is it so? The equal chords divide the circle into equal arcs. This arc is equal to this arc. Fine. This is just the property. You do not have to memorize this. And again, this another property of the circle: congruent arcs of a circle subtend the equal angles at the center. This is very important property. Property is nothing but what does property mean? It's just that you have to remember all of these concepts. For example, if you have 2 equal arcs here, beta. If you have 2 equal arcs, what is this arc here? If you draw an angle to this arc, so this is an arc, right? DC is an arc. So if you draw an angle, the angle subtended by this is DOC, right? And if you draw this arc, this is an arc now. ABO. This is an arc now, right? If for this arc, the angle subtended AOB and DOC are equal. So this is one property, okay? DOC is equal to AO. So 2 properties we have learned: equal arc subtend, equal chord subtend, equal arcs. What is it, beta? Equal arcs, equal chords, equal arcs. Correct? Correct?
Yes.
Equal chords, equal arcs. Equal matlab congruent or equal arcs. And the other property is equal arcs subtend, equal angles. ठीक है? समझ में आ रहा है लाइबा? These 2 are the properties. Now we are going to a theorem. Theorem हमने क्या सीखा था? Is it theorem number 7? Yes. What was the theorem beta? If there is an arc DC and if you subtend an angle like this at the center and at any other point, then the angle formed at any other point is the angle formed at this center of the circle, and this one is it is twice of the angle formed at the center of the circle. Correct?
Yes.
Yes. So the center of the circle is 2 times the D. If you write it A, then it is DAC. Okay? 2 times DA is nothing but DOC. Right? This was the theorem number 7. Have you memorized this theorem 7?
Yes.
Yes. So you have understood how to prove it, beta? Any doubts in that?
No.
No, that's great, mashallah. So this is, see the theorem, please. The angle subtended by an arc at the center is actually double the angle subtended by it at any point remaining part of the circle, which is drawn at the remaining part of the circle. So for this example, if you draw something at the center of the circle, if this is an arc AB, if this is an arc AB, if you draw a angle here, okay, let this be AOB, then if you draw any point here, let it be C, or any point here D, let this be D. If you draw an angle or subtend an angle at here, and if you subtend an angle here, then the angle ADB or ACB, fine beta, ADB or ACB, this will be twice, the twice of angle ACB will be equal to this, fine, will be equal to AOB. So AOB is equal to twice of angle ACB. Understood? So AOB is equal to twice of angle ADB. Correct?
Yes.
Yes. So understood? So this is nothing but angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining parts of the circle. This can be taken into three different diagrams. So one PQ arc is forming POQ here, and here it is PAQ. So this angle is equal to POQ is equal to 2 times the angle PAQ. This is what you're going to prove, right? 2 times the angle. This angle POQ is equal to 2 times angle PAQ. This is what you're going to prove in all of these, right? So
Yes.
there are three different cases. One case is if the arc is at the center of the circle. If the arc is actually half of the circle, then there is another case. But all of these are same. If the arc is greater than the or it is major arc, then what happens? These are three different cases. All of three have the same proof, right? Just same proof. You will just have to prove that angle POQ is equal to 2 times the angle PAQ. Fine? Fine with it? Any doubts here, beta?
No.
All right?
No.
Any doubts here?
No.
Let's move forward. Okay, you just have to revise this at home and again, inshallah. So this the theorem number 8 is angles in the same segment of a circle are equal. Fine. What does this mean? Angles in the same segment of a circle are equal. Okay, the meaning of this is, beta, for example, I'll tell you. Aisha, if you have the circle, fine. Sorry, Laiba, if you have the circle, if you're having AOB as an arc. Now, previously, what did we study? If you draw something like this, if you draw something, see here, and if you draw something in this way, okay, if you draw a point and subtend an angle ADB here, if you draw something and AEB here, okay, angles, these angles, beta, the angle E, the angle D, and angle C, this all will be equal, okay? Isn't it interesting? Yes, all of these angles will actually be equal. You have to remember this. Fine, beta? Why is it so? Because there is something we can prove it through the theorem. Can you hear me? Am I audible?
Yes. Yes.
Okay. Is it fine now? Have you understood what concept is it? It is nothing but angle in the same segment of the circle. They are actually equal, which are subtended by the arc are actually equal. So angles in the same segment of the circle are equal, and these angles are actually subtended by the arc of the circle, right? For example, here, beta, there's a diagram here. Just see it. PQ is an arc here, okay? This PQ is an arc. PQ is subtending an angle at the center. Fine, this is fine with you. Now A and C are the 2 points on the circle, and now they are making it subtend the angle PAC and angle PAQ and PCQ. Okay. Now which angle should be equal? What you have to prove now, beta? Is it not this and this you have to prove? Yes, right? You have to prove PAQ is equal to PCQ, right, beta?
Yes.
Yes. How would you prove this? It is actually very easiest proof. Should I tell you how you prove this? You have the previous theorem. What do you have in the previous theorem? Is it not angle POQ is equal to what? What was in the previous theorem? Angle POQ is equal to how many times? 2 times? Angle P? Yes, please. PA? Q, right?
Yes.
Angle P, this angle beta, POQ, we have proved it recently, right? Is equal to 2 times the angle PAQ. Okay, if you want to consider this C the point, then angle POQ is equal to POQ is again equal to 2 times the angle PCQ, right?
Yes.
From equation 1 and 2, POQ is equal to 2 PAQ, POQ is equal to 2 PCQ. Can we not write 2 PAQ is equal to 2 PCQ? Yes, right? Both left-hand sides are equal here, beta. POQ is equal, POQ is equal. If two left-hand sides are equal, then can we not write 2 PAQ is equal to 2 PCQ?
Yes.
Yes, right? See here. Angle POQ is equal to 2 times PCQ. Or it is also equal to 2 times PAQ. Fine. So 2 cancels out. PACQ is equal to PAQ. PCQ is equal to PAQ. This is the proof. That's all. Understood?
Yes.
Any doubts here? No. The previous theorem stated as that angle POQ is twice the angle, this one, that is subtended at any point. Correct?
Yeah.
Yes. If we consider this as another point, then POQ is also equal to 2 times the angle PCQ. This was a theorem number 7. Do you remember this?
Yes.
Yes. 2 times this one. So 2 times PCQ is also equal to 2 times POQ, because POQ is equal to this one and POQ is equal to this one. So left hand side we can just ignore, and right hand sides, two right hand sides we can take equal from equation 1 and 2. So 2 PCQ is equal to 2 PAQ, 2 cancels out, 2 PCQ is equal to PAQ, sorry, PCQ is equal to PAQ. This is what you have to prove, that's all. Understood? Any doubts?
Yes.
Okay,
No.
that's good. This was theorem number 8. That's all. Now, theorem number 9 is actually the converse of theorem number 8. So, this is the last theorem that you're going to study here. Fine. You do not have more theorems after this, beta. You do not have any more theorems after this. You just have to memorize 2 theorems. They are not like any proof is there or something like that. They are quite easy. Okay. This is the last theorem that you're going to study. Can you tell me theorem 7, 8 now, please? What is theorem 7, beta?
The angle subtended by an arc is doubled
Yes,
to
excellent.
the angle subtended by it and the
It at the
point.
center of the circle. Yes, very good. Arc at the center of the circle is double the angle at any other point. Fine. What about the theorem number 8? It states that, yes, beta, it states that angles in the same segment, this one angle and this one angle subtended by the same arc of a circle are equal. Fine. This is smallest theorem. Fine. So this is theorem 8. Now we're going to last theorem, theorem number 9. It is nothing but the converse of the theorem number 8. इसका converse क्या होगा बेटा? Can you please tell me what it can be? It is just that you have to prove that same segment. This one you have to prove. Okay. So what you have to prove here is in the theorem number 8 that these points that are equal, that are formed are equal, then these points should be in the circle. Okay. They should be in the same line, or it should be in the collinear. That should be collinear. Okay. This is what we're going to prove. If you're going to subtend the angles from the arc, they will be equal. Okay. They will be equal only if the points A, C, D are collinear. Correct? This is the converse of theorem number 8. Converse मतलब इसका opposite क्या होगा? It is nothing but the angle subtended by the arcs at any points are equal only if they are collinear. ठीक है? Understood?
Yes.
That would be theorem number 9. So we have to prove that A, C, or something that we are going to draw, D or E or F, whatever points you're going to draw bit of, and I subtend it from the arc PQ. Then they are equal only if all of the angles are equal. All of these angles are equal only if these points are collinear. मतलब एक के पीछे एक होंगे. If they are lie on the circle, right? Only if they lie on the circle. If they lie outside the circle, can we prove that they are equal in angle? No, right? So they should, this all lines points should be collinear. We are going to prove that these points are collinear in the theorem number 9. That's all. Collinear का मतलब क्या होता है? In the same line, right? If this is a line, they should be in the same line. Correct? Correct, Laiba? Yes.
Yeah.
Now please read the theorem. If a line segment joining the 2 points subtends equal angles at the 2 other points lying on the same side of the line containing the line segment, the 4 points lie on the circle. So you just have to prove that the 4 points that we are subtending all lie on the circle. Okay. If the line segment, okay, do you have any doubts here? If a line segment joining 2 points, okay, if a line segment joining 2 points subtends equal angles at 2 other points. For example, if this is line segment, okay, this is an arc for you and this is a segment for you. Okay, if a line segment joining 2 points, this and this is a line segment joining 2 points, right? AB. Let's consider this is an AB. This is a line segment AC, right? AC and CB are line segments that are joining the 2 points AB. Fine?
Yes.
Yes. If line segment joining 2 points subtends 2 points, okay, let this be another point as D. Okay, subtends equal angle at the 2 other points lining on the same side of the line containing the line segment, then these 4 points are also already collinear. Okay, I'll tell you how you have to prove this point. Okay, you will understand when you're going to prove it. Okay, so here beta, it's quite easy. Okay, just see this one, what we are going to prove. If a line segment joining 2 points, okay, subtend equal angles at 2 other points lining on the same side of the line containing the line segment, the 4 points lie on the circle. So how would you prove this? It is nothing but this line. You already know this line is equal to this line. Okay. Now if they draw some other points on the same line beta, inside and outside circle, then you have to prove that all these lines, all these points should be collinear. For example, A, B, C, and D should be in the same circle. You have to prove that A, B, C, D are in the same circle. That's all. Okay. So to prove this, we are actually taking the converse of this and proving it. Okay. It's quite easy. If you just concentrate, you will understand it better. Fine, Vita?
Yes.
Just concentrate here. Now, AB is a line segment, they have told. Okay. If a line segment joining 2 points, AB is a line segment. Fine. It is joining 2 points AB. See here, joining 2 points. Fine. Now it subtends equal angles. They have already told that it is subtending two equal angles. This is fine. Two equal angles. Next, they are telling angles. Two other points lining on the same side of the line. Two other points is E and E dash. ठीक है? अब समझ में आ रहा है? E and E dash are two other points. Now this all of the angles are equal. What are they telling? All of these angles, 1, 2, 3, all are equal. And what they are telling us, these lines are co-cyclic, concyclic, or they are on the collinear. These points are collinear. They should be collinear and lie on the same circle. So A, B, C, D should lie on the same circle. That is what you're going to prove. It's a very easy theorem. We do not have any long proofs of something like that. You just have to, what is given, right? What is given? AB is a line segment which subtends the equal angle at the point C and D. We know it already, right? We know that ACB is equal to ADB. Yes or no? ACB is equal to ADB. It was one property of the arc, right? One property of the arc. Was it the theorem? Theorem number 8, na beta?
Yes.
Segments subtend the equal angles, right? Equal segments subtend the equal angle. So it is ACB, theorem 8. It is nothing but ACB is equal to AB D. This 2 is already given. So what to prove that point A, B, C, D are collinear. Collinear का मतलब क्या होता है? Lie on the same circle, lie on the same line. ठीक है? So they are collinear or they are concyclic. They say actually. They do not tell linear. Linear का मतलब straight line होता है. So what we say is concyclic. एक cycle में है, ठीक है? They lie in single cycle or single circle. ठीक है? We are going to prove that the 4 points lie on the circle, not the collinear thing. Okay, collinear का मतलब same line होगा, correct? So it is not in the same line, but in the concyclic pattern on the same circle. Fine. So A, B, C, D lie on the same circle. How do you prove this? It is nothing but let us draw a circle through the points A, C, B. We already know that if you have just A, B, C, D, then let's go draw a circle A, B, C, D. That is already done. So suppose it does not pass through the point D. Okay, now we are just supposing that this circle is not passing through. Suppose, okay, we are just supposing. So we are supposing this and we are negating the answer. After negating the answer, we are just telling that it should lie on the circle. Okay, to negate this answer, suppose it does not pass through the point D and it passes, this circle passes through the point E, then it will intersect AD or extend AD. If you extend AD, then what at point it can intersect? Let it intersect at point E. If the circle, for example, is this much, okay, AE, B, then ACE and B lie on the circle. How would we prove this? Angle ACD is equal to angle AEB. Is it ACD is equal to AB? Is ACD is equal to AB? Last time did we prove that if this angle is this one? Yes, beta.
Yes.
If this angle is this one, if this angle is this one, do we not have one property in some parallelogram or something? The interior angles are equal. Yes, right? The straight, there is a straight line and the angles here are subtended are same, and these lines are actually parallel to each other. If the lines are parallel to each other, then the angles subtended at the inside are actually equal. Fine.
Yes.
Fine. So this ACB is actually is equal to AEB also, because this angle will be same as this angle and this angle will be same as this angle. So ACD is equal to AEB because angles in the same segments are equal. But it is given that ACB is equal to ADB, but we know that ACB is equal to ADB. So ACB is equal to ADB and ACB is equal to AB. Then what is it comes into picture? ADB is equal to AE. So ADB is also equal to AEB. Correct? ADB is equal to AEB. But this is possible only when E coincides with D, right? When this E coincides with D, it is only possible. So similarly, E dash should also coincide with D. So A, B, C, D are concyclic. This is how we are going to prove. We are going to negate something and then we are going to prove it. Can you understand this, beta? It's kind of a जिसमें words ज्यादा है, ठीक है? It does not have any proof like kind of angles and more, and it has words in the more pattern. That's all. You just have to write some statements here to prove this.
Yes.
That's all. Okay. So first they are negating it that they do not lie, and then they are proving it that they lie in the plane. That's all. Just the thing here: ACB is equal to ADB, ACB is equal to AEB. Fine. And then this and this 1 and 2, if you just tally, then ADB is equal to AEB. If ADB is equal to AEB, this is possible only if everything coincides. So they should always lie on the same circle. So ABCD, all the points are concyclic. That's all. That's all is theorem number 9. Understood? Though the statement is big, better, but it's actually easy. Can I tell you how easily you have to say this? You just start considering from the point AB. Okay, let there be 2 points. If there is a line segment and it has 2 points, fine. Okay. Laiba, can you hear me out?
Yes.
Yes. If there's a line segment which is joining the 2 points AB, then it actually subtends the equal angles, right? Equal angles on the two on the sides of the circle. Fine. This is already known. Okay. If you draw 2 other points on the circle and which are lying on the same side of the circle, then these points, then the angle that is subtended are actually equal, and these points are actually concyclic or lie on the circle. All of these points A, B, C, D are concyclic and they lie on the circle. That's all. Fine. So there is one unique property of the circle. You just have to remember this. I would have added it backside behind this one with the previous properties, but it is actually very easy property. That is nothing but angle in the semicircle is always a right angle. Okay, you just have to remember this. Angle in a semicircle is always a right angle. Semicircle का मतलब क्या होता है बेटा? Half of a circle, right? If this is a 90 degree, if this is an arc that is drawn, what is the chord now? This is AB. What is the chord now? If you write it a half here, what is the chord name, beta? Is it not diameter? Yes. Half of the circle, how we can form? By only drawing the diameter. Now this is an arc. Okay, fine. The angle in a semicircle is a right angle. Now if you subtend at any angle at a point, with any angle at a point, then if you draw it from here till here, or if you are subtending an angle here, and if you draw from here till here, then this angle that is subtended, it will always be 90 degrees. You just have to remember this. It will always be 90 degrees. Okay, this is a unique property only for the semicircle. Okay?
Yeah.
You have to remember this. Even there is a proof, small proof. How we can do this? Angle in a semicircle is a right angle. You just have to draw one PQ and then you draw some point PAQ. Okay, then you have to show that angle PAQ or anything like that is actually equal to 90 degree. How would you prove this, beta? It's quite easy. Let's start with this. Here PAQ is an angle that is produced by the segment or this arc. Let this be. We already know that. What is an angle PAQ? Do we not know that it is? What is angle PAQ, beta? If you draw something in like this, beta, if we draw some arc like this, it actually subtends it into 2 equal parts, right?
Yes.
Yes. So it is 2 times, or it is half of what? Angle PAO, correct? Angle PAO or PAO, or what is it? It is half of angle. Is it not half of angle PAO?
Yes, it is.
Yes, it is. So it is half of angle PAO. So if we draw something in this way, striking pattern, so this is half of angle PAO. No. There's something wrong here. Can you please tell me what? Whenever you have an angle subtended like this, do you remember it is 2 times of something? Yes. Do you remember? What is it, beta? Do you know POQ is 2 times the angle subtended at this one? What is it? PAQ. Do you remember this formula?
Yes.
What is this? It is a theorem number.
7.
Theorem number 7. Excellent. What is it states? The angle subtended by the arc. So angle POQ is an angle subtended by the arc is equal to, POQ is equal to 2 times the angle PAQ, right? Yes. Angle POQ is 2 times the angle PAQ. It's right. Now to find POQ, how do we do this? POQ is actually equal to 180 degree, right? Because it is a straight line. 180 degree and to what we do, we send it here. 180 degree divided by 2 is equal to PAQ. Now it's very easy. What is PAQ now, beta? Is it not equal to 90 degree? Yes. Understood? Any doubts here? I'll tell you how. See, we know that angle POQ, fine? Sorry. Angle POQ is equal to what, beta? 2 times angle PAQ. Why is it so? Because angle subtended by the arc of a circle is twice the angle subtended at the center of the circle, right?
Yes.
Twice the angle subtended by the arc at any other point is equal to the angle subtended at the center of the circle. Fine, POQ is equal to 2 times PAQ. This is already known, correct? This is our angle that is subtended by the arc, POQ. So we know POQ is a straight line, so it is 180 degree. 180 degree is equal to 2 times the angle PAQ. Is it right? So what is
Yeah.
angle PAQ now? PAQ is nothing but 180 degree divided by 2. This is not given in the textbook probably, but this property is given. You will be asked to prove this beta. Please write it down if you want to write it down, okay? This is somewhere near theorem number 7. This is given somewhere near theorem number 7. The property, this one unique property of the circle. And this angle in the semicircle is right angle, okay? Always the angle subtended by the semicircle is a right angle. Fine, you just have to write 3 lines. POQ is equal to 2 times PAQ. We know this by theorem number 7, right? Then 180 degree is equal to 2 times PAQ. 180 degree over 2 is equal to PAQ. That's all. 180 degree 2 is divided by 2 is nothing but 90 degree. So POQ, it's not PCQ, it's PAQ, okay? Okay, we are just getting confused with the words here. It is PAQ, fine? It's PAQ here. Any doubts still here, Vita?
No.
No, this was easy, right? Have you written it down? Just write it somewhere in the book or just in the pencil at the side of your textbook. That is nothing but PAQ. How did we prove this? POQ is equal to 2 times PAQ. So, what is POQ? Actually, it is 180 degree. Why is it 180 degree? Can you please tell me? POQ is a straight line, right? It is a diameter. So, this angle is always equal to 180 degree. 180 degree divided by 2 is equal to PAQ. So, PAQ is equal to, what is it, beta? 90 degree. So, instead of C, it is A actually here, okay? I just missed that out. So you find another property of the circle that angles in a semicircle is always a right angle. Understood?
Yes.
Okay, we have the last concept that is called as cyclic quadrilaterals. We can do it now. Okay, we just have 5 more minutes left. It's very easy, okay? You just have one property that is, what is cyclic quadrilateral? It is nothing but a quadrilateral ABCD is called cyclic if all the 4 vertices of it lie on the circle. That's all. Quadrilateral, what is quadrilateral? Come on, tell me what is a quadrilateral? Quad matlab 4, right? It should have 4 points. That's all. If you have 4 points here, 1, 2, 3, 4, you can join this point and make many shapes. What did we study? How many shapes can we make? We can make square, we can make rhombus, we can make rectangle, we can make parallelogram, we can make a kite, right? All these were the shapes that we can make in the parallelogram. Now, what does concyclic mean? What does concyclic mean? What does cyclic quadrilateral means? For cyclic quadrilateral का मतलब होता है a quadrilateral if it is inside the circle, if the vertices lie on the surface of the circle, then that is called as a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral in which all the 4 vertices lie on the surface of the circle. Okay? For example, if you join A, B, C, D, then this quadrilateral is called as cyclic quadrilateral. Fine, beta?
Yes.
Fine, Lava. So A, B, C, D. This is a quadrilateral, right? They actually, if you form a circle around these points, if all of these points A, B, C, D lie on the surface of the circle, then this quadrilateral is called as cyclic quadrilateral. This is the last concept in this entire chapter. Okay, we had studied theorem number 1 to 9. Is it 9 or 8? 9 theorems we have studied in this chapter, and we have studied the cyclic quadrilateral concept. It is nothing but a cyclic quadrilateral is nothing but it is a quadrilateral in which all of the 4 vertices lie on the circle. That's all. All of the 4 vertices A, B, C, D lie on the circle. There, see here. This is a quadrilateral. This is a cyclic quadrilateral. Fine. Please define again, Vita. Please define again. What is a cyclic quadrilateral? All the points A, B, C, D of the quadrilateral lie on the Circle, right?
Circumference.
Surface of the circle. That's all. They lie on the circle. All the points A, B, C, D of the quadrilateral lie on the surface of the circle. So it is called as a cyclic quadrilateral. It has two simple theorems. It is nothing but all the sides, if they are added, it gives you something, and the opposite sides, if added, gives you something. These are just the two theorems. You just don't have to memorize, or you do not have to prove all of these. It's just the statements. The sum of either pair of the opposite angles of a cyclic quadrilateral is 180°. And the next theorem states that the sum of the pair of the opposite sides of a quadrilateral is 180°, then that quadrilateral is called as cyclic. So theorem number 10 and 11 are same as each other. It is nothing but this angle and this angle. If you sum both of this angle, then it is 180°. Fine. This angle and this angle, if you sum up, then it is 180. That's all. This is theorem number 10. And for the theorem number 11, what did we suggest, beta? It is nothing but the opposite of theorem number 10. It states that if the opposite angles are equal to, sum of opposite angles equal to 180°, then that quadrilateral is called as cyclic quadrilateral. Cyclic ka matlab, it is on the same circle. That's all. Now please tell me theorem 10 and theorem 11. What is theorem 10?
Sum of either pair of opposite angles of a cyclic
Yes. Of a cyclic quadrilateral are equal to 180°. Very good. You have to remember cyclic quadrilateral, okay? Cyclic quadrilateral, matlab, it is nothing but the points of the cyclic quadrilateral lie on the surface of the circle. What about theorem number 11? It states that, yes,
the sum of pair of opposite angles of quadrilateral is
equal, then that quadrilateral is
cyclic.
cyclic. Yes, very good. Excellent. MashaAllah. Barakallahu fiki. This was it. This was the session for today, inshallah. Tomorrow we'll have just the exercise problem, inshallah. You have to be well prepared with all of the concepts, beta, please. Because the next exercise or next example problems is based on all of the concepts that we had discussed in today's class. That's all. Theorem number 7 to theorem number 11. Okay? We are going to study theorem number 7 to 11. Only the problems on theorem number 7 to 11. Okay? Theorem number 11. Fine? So, the homework for tomorrow, please. You're going to write homework for tomorrow as theorem number 7 to theorem number 11. You have to memorize this and write down the statements of all of this theorem in your book without seeing, please. Okay? Will you do it, inshallah? Yes, Laiba? Can you do this?
Yes.
Okay. Any doubts in today's session?
No.
No. We have discussed theorem 7, theorem 8, theorem 9, theorem 10, theorem 11. Theorem 10 and 11 were based on cyclic quadrilaterals. Do you remember? Cyclic quadrilaterals. And theorem 7 to 8, 9 were almost similar. They were based on arcs. Theorem 7 was already done. 8 and 9 were done now. And theorem 7, what did it state? It was nothing but, what is the statement of theorem number 7, Bita? The angle subtended by the arc is twice of the angle subtended at the center. What was theorem number 8? The angles subtended are equal, right? Angles subtended are equal. By the arc are equal. By the segment are equal. What about theorem number 9? It states that the points are collinear in the plane if these are equal. If the points are equal, then they actually have to lie in the collinear space. If this is AB, the line segment, and we have some CD as points, then they all should be collinear or concyclic. Concyclic. We do not use the term collinear. We use concyclic here because they lie on the same circle. Okay. So theorem 7, 8, 9 are done. 10 and 11 has nothing but cyclic quadrilaterals. 10 states that sum of opposite angles in a cyclic quadrilateral are equal to, what is it equal to, beta? Is it equal to 180°? Yes. Sum of the opposite angles on a cyclic quadrilateral are equal to
180°.
180°. Excellent. What is theorem number 11? If it is 180°, then the quadrilateral is said to be cyclic quadrilateral. That's all. MashaAllah. Alhamdulillah. We are done with all the theoretical concepts till now in the circles. We just have one exercise left. Inshallah, we'll do that in tomorrow and day after tomorrow's class. Inshallah. Be well prepared for tomorrow's class, beta. We are going to ask some questions. I'm going to take tests test on Thursday, okay? Not tomorrow, but be well prepared, okay? Inshallah. Just revise all of the theorems and terms so that it will be easy for us to understand the example as well as exercise problem that is remaining, okay? We just have one exercise left, inshallah. It will be very easy for you if you have understood all of this concept till now, okay? Jazakumullahu khairan. Take care of yourself. Assalamu alaikum wa rahmatullahi wa barakatuh. Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta astaghfiruka wa atubu ilayk.
Walaikum assalam wa rahmatullahi wa barakatuh.
Alhamdulillah.